Hello, and welcome to Teledyne SP Devices. My name is Thomas Elter, North American Field Applications Engineer. Today I'd like to talk to you about pulse detection. We have the capability of our firmware package added on to our high-performance digitizers like the ADQ14, ADQ7, that package being called the Firmware PD, that allows us to do this type of analysis. For this demonstration, we've created a signal here where we have three different pulses with different attributes, and you can see that there is a slow variation in the baseline of this signal. Typically something like that you might see with thermal effects and other effects in the system. So to do proper pulse detection analysis, you need intelligence. You need intelligence for triggering, recording, and data collection. But before we apply that intelligence, we need to stabilize this signal. So we will apply our digital baseline stabilization, which is represented here by the red line, is the threshold that we had set for that. And you can see in the blue trace now how that signal has stabilized. The gray trace in the background is still fluctuating up and down, which was the original trace. Now we can begin to apply the intelligence. That will be with our triggering. With our triggering, we can set up a detection window to only acquire the pulses of interest. And as you can see on the screen here, this blue trace represents that detection window. And within that detection window, as you see, we have the two pulses, but we want to have intelligent recording, so we only acquire the information about the pulses itself. We may want to suppress the zero baseline here, so we're not collecting that extraneous information. So we will apply our triggering to help with that recording aspect. So we set a trigger level for the rising and falling edge, in this case set to the same level, and we also apply what we call leading edge and trailing edge windows so that we gather the appropriate information on the rising and falling edges of the signal. So you can see here now by the blue trace, we've got just the pulses themselves within the acquisition record, and all the gray trace is the suppressed data, or as we call zero suppression. This is the beginnings of extreme data reduction. The next thing that we can apply is the signal processing to get the peak value of these pulses, the pulse width or time over threshold, and the timestamp of those peaks. That metadata, along with the raw data, which is the blue trace, is available to you. If you want further extreme data reduction, you can just obtain the metadata itself. And so we can apply that here. And you can see here now you would just get the peak values, the pulse width or time over threshold, and the timestamp of the peak values. In this instance, we've reduced the data from the original acquisition window, which was roughly 2.4 megabytes worth of data, to now roughly 16 bytes of data for the metadata attributes of these pulses. You're also able to get the raw data with the metadata if you choose. This is the conclusion of the brief demonstration of some of these highlights. For further information on our Firmware PD package and our advanced digitizers, go to our products page and documentations page on our website, or contact your local sales representative. Thank you for watching.